Hello, welcome to Solving Trigonometric Equations with Angle Formulae. So what we'll be doing in this one are our compound angle formulas, so sum and difference of angles. We'll be doing double angle formulas, we'll be doing complementary angle formulas, and some trig identities and things like that. So all stuff that we have learnt before. Some of these are going to be pretty hard, and you just need to practice as many examples of these as you can. We won't be doing the T formulas because the video will be way too long, so I'll do a separate video with just T formula examples. Okay, let's get into it. Okay, first example for today, we have solve the equation cos x plus 3 pi and 4 equals square root of 2 sine x. We're solving from 0 to 2 pi. So when we see the left-hand side, we should be thinking our compound angle formula. So we've got cos A plus B equals cos A cos B minus sine A sine B. So that's what we should be thinking. So of course our A is x and our B is 3 pi and 4. So let's make our substitution. So we'll have cos x cos 3 pi and 4 minus sine x sine 3 pi and 4. And that's going to equal square root of 2 sine x. Now these are exact values that I know. Cos 3 pi and 4. 3 pi and 4 is in the second quadrant. Cosine is negative. Be negative 1 on root 2. Sine 3 pi and 4, that's positive 1 on root 2, but I've already got that negative in the middle there, so it's still going to be minus 1 on root 2 sine x. Here if I multiply everything by root 2, then I'll have minus cos x minus sine x, and root 2 times root 2 is 2. Group my sines together, add sine x to both sides, I get this. And then now at this point, if I do sine divided by cosine, I'll end up with tan. So I'm going to divide both sides by cosine, so I'll get negative 1, 3 tan x. Divide both sides by 3. Okay, and then inverse tan. And when I put that into my calculator, I get my base angle. This I get minus 0.32175. Okay, now that is giving me the fourth quadrant because that's where tan is negative. But of course I want my answers in the second and fourth quadrant, but between 0 and 2 pi. So my answers will be, second quadrant will be pi minus that, and my fourth quadrant will be 2 pi minus that, and so my final answer is 2.82 and 5.96. Okay, example number 2, we're going to solve the equation cos 2x minus cos x equals 0 for 0 to 2 pi. Alright, we're going to go through two different ways that we can solve this one. So the first method we'll use is cos 2x, we're going to use our double angle formula. So the one that we're going to want to substitute is cos 2x is the same as 2 cos squared x minus 1. And then we've also got the minus cos x, and it equals 0. Alright, and then that creates a quadratic, so we can factorize, but before we do that, I like to write my quadratics like this. So my a is 2, b negative 1, c negative 1. This one does factorize, otherwise we could potentially use the quadratic formula. Okay, so it factorizes to this. So 2 cos x plus 1 could equal 0, or cos x minus 1 could equal 0. So cos x, because negative a half, when is cosine when is cosine negative 1/2? Well, that base angle, cosine 1/2, is pi on 3. Okay, but we want to get the correct quadrants, which is, for negative, is the second and third quadrant for cosine. So second quadrant will be 2 pi on 3, and the third quadrant will be 4 pi on 3. Okay, for the second one here, when is cos x equal to 1? Oh, remember that cosine starts at 1, so it's 0, and it's every 2 pi. So our final answer is 0, 2 pi on 3, 4 pi on 3, and 2 pi. Okay, that's one method. Second method that we could do is we could say cos 2x is equal to cos x. Now, if I take the inverse cosine of both sides, I get 2x could equal x. That's in the first quadrant, but it could also be 2 pi minus x in the fourth quadrant, 2 pi plus x, that's the first quadrant on the next cycle, and it keeps going like this. Fourth quadrant, first quadrant, and so on. Now this is a bit of a tricky equation to solve, because here I've got the first one and each odd one, first one, third one, fifth one, I've got a plus x, and each even one, second, fourth, sixth, I've got a minus x. So I want to separate them. So I want to have 2x equals x. I'm going to have all my ones that have a plus x. So 2 pi plus x, 4 pi plus x, and that would keep on going. And how would I solve this? I just would subtract x from both sides. So this one becomes 0, 2 pi, 4 pi, and so on. I'm already too big, so I don't need to keep going. My second group will be all the ones that have a minus x. So it's going to be 2 pi minus x, 4 pi minus x, 6 pi minus x, and so on. And how would I solve this? I'm going to need to add x to both sides. So 2 pi, 4 pi, 6 pi, and then divide everything by 3. And 2 pi is already at the edge, so I don't really need any more. So combine those solutions together, we get the same answer as before. 0, 2 pi over 3, 4 pi over 3, and 2 pi. Two different ways to solve the same problem. Next example that we have here, use the expansion of cosine 2 theta plus theta to obtain the expression of cosine 3 theta in terms of cosine theta. Well, 2 theta plus theta is 3 theta, but what we want to use is the compound angle formula, the addition of angles formula with cosine, and hopefully we can get it into an expression with cosine theta. So let's get started. We know cosine 2 theta plus theta will equal cosine 2 theta times cosine theta minus sine 2 theta sine theta. Now here you can see we have two of our double angles. So cosine 2 theta, we want to change it into the one that involves cosine theta, because that's what we're writing it in terms of. And sine 2 theta, we only have the one double angle formula there. So this will be 2 cos squared theta minus 1 cos theta minus 2 sine theta cos theta sine theta. Now sine theta times sine theta is sine squared theta, so I'm going to change that is going to become 1 minus cos squared theta, which is my trig identity. So let's expand and group our like terms. We're going to end up with 2 cos cubed theta minus cos theta minus 2 1 minus cos squared theta, that's my sine squared theta, and then cos theta. So it is 2 cos cubed theta minus cos theta. Let's change that. So 2 cos cubed theta. There we go. And this one will be negative 2 cos theta, and then negative 2 times negative cos squared times the cos squared will give plus 2 cos cubed theta. So group all our like terms. Well, this will be cos 3 theta, and it's 4 cos cubed theta minus 3 cos theta. Okay, second half of this question says, hence find the roots of 4x cubed minus 3x plus a half equals 0. When we see that keyword hence, we know we should be using what we just found. And what we just found was cosine 3 theta is the same as 4 cosine cubed theta minus 3 cosine theta. So if we have a look at what we've got here, if I let x equal cosine theta, then I get 4 cosine cubed theta minus 3 cosine theta plus a half equals 0. Okay, now hopefully you guys can see that this is cosine 3 theta. So cosine 3 theta equals negative 1/2. So when is cosine 1/2? Well, that is base angle of pi on 3, but of course we want negative, so we want 3 theta to be, when is it negative? That's the second and third quadrant, so that's going to be 2 pi on 3, 4 pi on 3, and eventually I'm going to divide everything by 3. So I'm going to keep adding a few more. I'm going to add the next cycle. So I'm going to add 6 pi on 3 to each of these. So I'm going to end up with 8 pi on 3, 10 pi on 3, and let's go one more, 14 pi on 3, and 16 pi on 3. And then I'm going to divide everything by 3. So I'm going to have 2 pi on 9, 4 pi on 9, 8 pi on 9, 10 pi on 9, 14 pi on 9, and 16 pi on 9. Okay, now we're not trying to solve for theta, we are trying to solve for x. So remember that we let x equal cosine theta. Now, if we look at our answers here, we have this one, which will be in the first quadrant, and this one, which will also be in the first quadrant. So these are going to be two different roots. Now, we know we have a cubic, so we might have up to 3 roots. And this one here, the next one here, is in the second quadrant. So actually I don't want to write second here, this is the first quadrant. So this is also in the first quadrant, but it's going to be different, and this is in the second quadrant. So these are going to be 2 positive answers. The third one's going to be a negative answer. And we can see, because it's actually symmetrical, that these answers all here will actually just give the same values. So we don't need those anymore. So our final answer is x is cosine 2 pi on 9, cosine 4 pi on 9, and cosine 8 pi on 9. And they are our 3 roots. Okay, another example here. We have solved the equation cosine 3x minus sine x equals 0. We're going from negative pi to pi. Okay, so what we can do here is we can say cosine 3x equals sine x. However, it's a bit of a problem because we've got cosine 3x, we've got sine x. Maybe if they were both the same, we could work with tan or something like that. But we can't do that in this example. But what we can do is we need to remember one of our complementary angle identities. Sine theta is cosine pi over 2 minus theta. So we can use this result to change our right-hand side here. And it's also vice versa, right? So we could have had cos theta is sine pi over 2 minus theta, but anyway, this is what we've got. So cos 3x equals cosine pi on 2 minus x. Take the inverse cosine of both sides, and this one is a pretty similar question to what we did in an earlier example. So that is our first quadrant, but we also have our fourth quadrant where they're the same. So that'll be 2 pi minus pi on 2 minus x, and 2 pi plus pi on 2 minus x, and then 4 pi minus pi on 2 minus x, and that's going to keep going on. Okay, so that's our pattern. So we're going to have to separate this into the ones that have a minus x and the ones that have a plus x. So let's start with 3x equals, so we'll start with the first one, pi on 2 minus x. So the other ones that will have a minus x will be all the odd ones, so 1, 2, and the third one, but we didn't write it, but that's okay. We'll figure out what it is. So it'll be 2 pi plus pi on 2 is going to give me 5 lots of pi on 2, and then it will be minus x. Okay, the next one will be 4 pi plus 4 pi plus will be 9 pi on 2 minus x. Hopefully you can see the pattern now. So the next one would be, I keep adding 4, so it'll be 13 pi on 2 minus x. Dot, 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 dot. No, just keep going. I want to add x to everything, so I get 4x, pi on 2, 5 pi on 2, and 9 pi on 2. Divide everything by 4, so it's pi on 8, 5 pi on 8, 9 pi on 8. That's already too big, isn't it? And so what we're doing here is, hopefully you can see that all of my answers will be plus 4 pi on 8, okay? If I wanted to keep adding more, but obviously I'm thinking about my domain here, negative pi to pi. So I can also go backwards. So if I was at 9 pi on 8 and I'm subtracting 4 pi on 8, so I'm going to put a minus there, and that's going to help us get our solutions at the end. Okay, let's think about our other ones, which would be 3x, 2 pi minus pi on 2 plus x if I expand that bracket. Next one will be 4 pi minus pi on 2 plus x, 6 pi minus pi on 2 plus x. So if I subtract x from everything, I get 2x, and let's group our terms here. So this will be 3 pi on 2. The next one will be 7 pi on 2, 11 pi on 2, dot, 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 dot. Hopefully you can see the pattern there. Divide everything by 2, so it's x equals 3 pi on 4, 7 pi on 4, and 11 pi on 4. Okay, so hopefully you can see the pattern here is that I am plus or minus 4 pi on 4. Okay, so if we're going to get our final answers, I'm just going to erase the top here and we'll go back up. So to get our final answers, because remember we want to go from negative pi to pi, so my final solutions will be, from the first one I go to negative 7 pi on 8, negative 3 pi on 8, negative pi on 4, pi on 8, 5 pi on 8, and 3 pi on 4. So they are all the solutions. If you follow these patterns here by going back, they're the ones that you will get that will fall between negative pi and pi. Okay, last example for this video. Solve the equation arctan x plus arctan 1 over 4 equals arctan 1/3. So with this one here, with all the inverse tan that's going on, you're probably thinking, well, what if I take tan of both sides and that works out pretty well on the right hand side because that just becomes 1/3. But on the left hand side you might feel a little bit stuck. But if we think about it, I've got tan and then I've got inverse tan x plus inverse tan x over 4. So this is kind of like A and this is B. So I can do this as the sum of angle formula for tan. So my sum of angle formula for tan, tan A plus B, is tan A plus tan B over 1 minus tan A tan B. Okay, so that's what I'm going to use, except my A is going to be inverse tan x and my B is going to be inverse tan x over 4. Okay, so I'm going to end up with tan inverse tan x plus tan inverse tan x over 4 over 1 minus tan inverse tan x and tan, let's get rid of this, tan inverse tan x over 4, and that's going to equal 1/3. Okay, now tan inverse tan, they're just going to cancel, so I'm going to end up with x plus x over 4 over 1 minus x times x over 4, and that equals 1/3. So on the top I end up with 5x over 4, and I can cross multiply here, so I'll end up with, well, let's just do one step at a time. 5x over 4 over 1 minus x squared over 4 equals 1/3. And now I can cross multiply, so I end up with 15x over 4 equals 1 minus x squared over 4. And I'm going to run out of room, so I'll get rid of the top here. Okay, multiply everything by 4, so I'll get 15x equals 4 minus x squared. Okay, so this is a quadratic, so I want to take everything to one side. X squared plus 15x minus 4 equals 0. Have a think about that. Can I factorize? The answer is no, but I can use a quadratic formula, so it'll be x equals negative 15 plus or minus 15 squared minus 4 times 1 times negative 4, c, over 2 times 1, and using your calculator 0.262 and negative 15.262. Okay, and that is it for solving trigonometric equations with angle formulae. Now that is by no means all of the type of examples that you can get, so just practice as many as you can find. I'll make a separate video for T-formula examples. Don't forget to smash that subscribe button and hit down with the likes and get the bell for notifications. I'll see you in the next video.